Today we are going to start with the important condition on differential equation, that is Lipschitz condition. If we talk about formal definition of a function which satisfies Lipschitz condition, then how we define? Let function fxy be a function of x and y defined in a domain D of xy plane, then this function fxy is said to satisfy Lipschitz condition with respect to y if mod of fxy1 minus fxy2 is less than or equal to k mod of y1 minus y2, where this k is constant and is called Lipschitz constant. And what are this xy1 and xy2? These are 2 points in this domain D, where these 2 points which we have discussed in this domain xy1 and xy2, they are 2 points in the domain defined. If any function satisfies this inequality, we say that that function satisfies Lipschitz condition. Or if it doesn't satisfy the condition, we say that the function is not satisfying Lipschitz condition. It means that there may be some function which don't satisfy Lipschitz condition. ऐसे फंक्शन भी हो सकते हैं जो Lipschitz condition को satisfy नहीं करते. It means there must be some condition in what case the function satisfies Lipschitz condition. So what is that? There is a theorem on this Lipschitz condition, and what is that? Statement of theorem is let fxy be a function defined in a domain D of xy plane such that curly f by curly y exists and is continuous in domain D then we say that the function fxy satisfies Lipschitz condition where this k is Lipschitz constant, and this constant actually find out by the formula list upper bound of curly f by curly y xy belonging to D. This. So what is the condition for a function to satisfy Lipschitz condition? The condition is given here कि जो भी फंक्शन आपको दे रखा है fxy, उस फंक्शन का पार्शियल डेरिवेटिव y के रेस्पेक्ट में एग्जिस्ट करना चाहिए फाइनाइटली, और उसका पार्शियल डेरिवेटिव y के रेस्पेक्ट में कॉन्टिन्यूअस भी होना चाहिए. इसके ऊपर न्यूमेरिकल भी आ सकता है, एमसीक्यू टाइप का न्यूमेरिकल भी. वो कैसे बेस्ड हो सकता है कि a function fxy satisfies Lipschitz condition if नीचे 4 ऑप्शन दे दे कि क्या क्या किस किस ऑप्शन के केस में वो सेटिस्फाई करेगा, तो उन केसेस में द करेक्ट ऑप्शन विल बी करली एफ बाई करली वाई शुड एग्जिस्ट एंड मस्ट बी कंटिन्यूअस। ये 2 कंडीशन होनी चाहिए उस केस में। सो वी मे प्रूव दिस आल्सो। Let the function fxy be the given function in domain D and let curly f by curly y exist and is continuous in domain D. So, by mean value theorem, we have curly f by curly y is equal to fxy1 minus fxy2 over y1 minus y1। What is this mean value theorem? ये चीज है ना आपने ग्रेजुएशन में पढ़ी हुई है। मीन वैल्यू थ्योरम कि फंक्शन इज कंटीन्यूअस, इट्स डेरिवेबल इन ओपन इंटरवल, कंटीन्यूअस इन क्लोज इंटरवल, देन देयर एग्जिस्ट अ नंबर c in interval a b such that f dash c is equal to f b minus f a over b minus a। इस तरह से पढ़ा हुआ है ना, ये थ्योरम आपने पढ़ी हुई है इस तरह से। सो वी हैव दिस वन। अगर हम इसका मॉडुलस लेते हैं, सो टेकिंग मोड ऑन बोथ साइड्स, we will have this one, and in that case from here fxy1 minus mod of fxy2 will be equal to curly f by curly y mod, this will be multiplied here, y1 minus y2, right? And now this is less than equal to least upper bound of curly f by curly y mod multiplied by y1 minus y2 mod, and if we replace this by the constant k, then this inequality gives you mod of fxy1 minus fxy2 is less than equal to k into mod y1 minus y2, where what is this k? This k is written in place of this number, and this is called Lipschitz constant. So this is the way how we derive the Lipschitz condition with Lipschitz constant, and only those functions satisfy Lipschitz condition whose derivative with respect to y exists, and it should be continuous. Now the next question arises, is the converse of this theorem true? Converse of this theorem true means कि अगर कोई फंक्शन लिप्सिट्ज कंडीशन को सेटिस्फाई कर रहा है, यहाँ तो इसमें तो क्या है कि अगर कोई फंक्शन ऐसा है जिसका डेरिवेटिव एग्जिस्ट करता है और कंटीन्यूअस है, तो वो डेफिनेटली लिप्सिट्ज कंडीशन को सेटिस्फाई करेगा। अब इसका कन्वर्स क्या होगा कि अगर कोई फंक्शन ऐसा है जो लिप्शित्ज कंडीशन को सेटिस्फाई कर रहा है, तो क्या उसका डेरिवेटिव कॉन्टिन्यूअस हो और उसका डेरिवेटिव एग्जिस्ट करे? ये जरूरी है क्या? सो द आंसर इज नो, एंड व्हेनेवर वी हैव द आंसर इन नो, वी मस्ट हैव सम एग्जांपल टू प्रूव इट। सो यू मे नोट डाउन दैट converse of this theorem is not true. For example, take a function, let fxy is a function x into mod y defined in domain D, that is a plane xy such that mod x less than equal to a and mod y less than equal to b. For example, this is the function. So first we will show that this function satisfies Lipschitz condition, right? For that, consider mod of fxy1 minus fxy2. So this is equal to, if we find out xy1, we just replace this y by y1. So what we have, xy1 minus fxy2, जब यहाँ से लिखेंगे तो we will write down xy2, right? Taking x common from both the terms, we have x y1 minus y2, and which may be written as less than equal to mod x multiplied by mod of y1 minus y2. And because we are given the region, क्या region है हमारे पास, domain क्या है, mod x less than equal to a. Therefore, this mod x may be replaced by a, and this further may be written as a into y1 minus y2. Hence, according to Lipschitz condition, this function satisfies Lipschitz condition with Lipschitz constant k having value equal to a. So Lipschitz condition को तो satisfy कर रहा है ये function, but its derivative does not exist at the point y equal to 0. Hence Lipschitz condition is satisfied by this function, but curly f by curly y, which is actually curly by curly y of x into mod y, is not existing at any point x, 0. जहां पे y की वैल्यू 0 है वहां पे ये फंक्शन कॉन्टिन्यूअस तो होगा, बट इट विल नॉट बी डिफरेंशिएबल, और डिफरेंशिएबल नहीं है तो कर्ली f by कर्ली y एग्जिस्ट नहीं करता. So we have an example that there may be function which satisfy Lipschitz condition, but it is not necessary that its derivative with respect to y will exist, or it may be possible that its derivative may not be continuous.